So my starting point to think about intelligence and biological intelligence. And we try to consider about the brain. Brain is the physical substance, and mind is is phenomenological substance. Then we can think about the intelligence in the midpoint. So then I really love to think about the biological intelligence, not hypercomputer, not automation, but all the style of the thinking in the biological intelligence is one of the key, I believe. で、知能っていうのは、まあ、こうインテリジェンスとこう略されるんで、これ辞書で調べるとこういうふうに出てきます。These variety of the function is represent the intelligence. Sometimes intelligence means represent some large variety of the meaning, but in the psychological field, generally, the creativity and the personality and the life is separated from the intelligence. I started the project of MNC company and making the machine and the laptop computer. Then quit the job and start learning mathematics, then enter the master grade and the doctorate course, then enter the weekend brain sciences to making the memory circuit, the brain, how we can remember your personal history. It's, usually we have many the experimental evidence of the rat brain. And the good news is this year the Nobel Prize, the John O'Keefe got to be the Nobel Prize. That's really concerned connected the my research. But then we really want to I really want to try to embed this system into the robot. So then I moved to the QTech 5 years ago. 社会や人間で助けるんですかということですね。I studied a lot about the experimental data in neuroscience, then tried to make a model of theory and an algorithm. Then, this is the work in the scientist, but I wanted to try to test it works really in a society embedded with the robot. Then, if it's interacting human society, human, it's really wonderful. Then it is kind of strong proof that theory is gives benefit for us. だから、こんなことを最初に考えました。Okay, the brain science, then we 専用に作るというのが王道です。これはいわゆるコンピューターの論理的。The computer, the machine is the rule-based, and some external the provider or the programmer make it. Then there's no bug here, and you should make it finally without any contradiction inside. Then 足もは。だけど足もくんがこうみんな now people are very kind, gentle for robot. If just a simple demonstration, you are excited. Oh, really like that. But this is simple. Just move the couple and bring it to the table. And so, but if it's human, you ask many things. I'm irritating. You have to bring it to more faster, something like that. And then so you have many complaints if it's against the human being. っていうものを大っていう意味に書き換えています。This is a really different thing. Okay, it's a program. It's a program. So if you assign this is a chair, you can sit here. Robot can sit here. But you can modify the meaning of this. For this is a stair. If you really want to get something in the top, right? This is the modification, the meaning. So then this is the outside the current robotics. それで、この直感的とかを書き始めます。こう卵を守るため。Where the surprising thing here, it put egg in the top, the leaf, but the problem is, the egg is drying by strong sunshine. So then, what I don't know what he thinks, what the parents think, but this fish is putting water again and again, only for the for prevention, the drying for their children. じゃあ一方でこの ね、真の結果、パスプランニング and adaptation and get targets is very important things for robotics. But really want to think about the perception action cycle. What do you think? What is the awareness of him? So then, okay, I really want to know that what he thinks. That at least we have to think that such a kind of perception cycle exists here. He has to know what he did, what happening, and what some action he doing. Then such a connection to perception as the action is very important to achieve this kind of thing. But some people say it's the kind of the program embedded in the DNA. Okay, this is the kind of the starting point, but I really want to know what kind of emergent the function embedded in the brain and the biological body. だから、やっぱり生物ならではの知能、バイオロジカルインテリジェンスを考えてみたいということがあります。それが、ロボット自身が自分で考えるっていうことだと、こう感じよ。だから、そこをやらないで何をやるんですかと谷先生はおっしゃる。Jun Tani, the famous guy, the cognitive robotics, taught me, okay, this is his experience. He saw the time robotic demonstration. Okay, robot demonstrate it, open the refrigerator, get things and bring it. It was a beer. But he thought seriously how robots feel. Okay, the robots think, this is the fine day. The people expect the beer. Okay, I understand that. Or, this is a chilly day. So then, okay, the beer is not good for him. Okay, I want to replace the choice or something like that. But the command is command, and the program is program. Just replace it. It's the kind of the reason, the kind of robotics. だからこれが分かるかっていうことを、これを単純に別に感情を埋め込めばいいとかそういう話ではありません。そもそも僕らがどういうふうに考えてるかが大事。だから2つのことを考えてください。1つはオペレーショナルインテリジェンス。だからこれはエンボディメントと思います。だからこれはセンソリーモーターインタラクションね。こういうことで、I figured this is OT. I have to avoid these things. They get information on the external world. This is the first thing. で、もう一つは、これがね、Operational Intelligence and Embodiment。たまたまかかったのでは、大きく違います。The putting order is quite different if it's intended action or the occasional action. If you have a plan to go somewhere, you have to avoid things then quickly. Or you just want to play. Okay, you can enjoy the rotation and finding some option and how you can use that. だからこの何を考えて何をしたいかっていうトップダウンのものとこのセンソリーモーターアクションが変わるわけです。Very contextual. If you want to get some stairs here, then you can use this stair. But if you are very tired, this is a chair. Then depending on the context, you can change the meaning and change the perception, what it means. What is the information is, not the statistical meaning. And what you perceive, what you put the name and in specific object. Its name is including the meaning. So then we have to think about it as information flow, what is happening, and dynamical change, and on the background mechanism, the principle, then you finally reach the biological information, very personal, very contextual information. So that's applicable. Then the emergent appear inside because of the such a biological mechanism. Then we can think about biological information is quite different or the traditional meaning and the information science. なので、 inside. If you consider about brain science seriously, it's a biological experiment. Okay, it does this okay, you can publish the many papers. But engineering is engineering. You have to make a safe system, robust system. It doesn't destroy unexpectedly. Then this is very fun thing. But very flexible. Brain is very flexible, very unstable. But we try to connect together for the future. なので、これからやっていく講義というのは、やれますということを、やれます。Okay, there's I explained the motivation why we have to learn about mathematics. This is the context. Then we have to use the mathematics for making the theory and the implementation. And then this is why we have to think about the mathematics seriously. And some of the good things, the biological guide to the mathematical modeling is published in many good books. This is one of the good books. I try. Okay, this is the message from this author that they emphasize the biology, the need of mathematics. Many people know, but they do not use the exactly. Then this book is explained. Then, それで渋谷交差点の話が出てきます。これはオックスフォードサーカスですね、イングランド。で、これ渋谷交差点で、ある意味外国の人の名物。This is the Oxford crossroad. This is the crossway in February. It's very famous. The crossway and very the people is very proud. So tough and the thing. それで、さっきの映像を見ていただいたわけでちょっと思い出してほしいんですが、これで何の現象を見たいですかっていう、速度の歩いてる速度のバランスキー、スピードオブモーション、バラエティ、ディレクションで、はい、どうぞ。人の数、ナンバーオブピープル。方向の方ですね。ディレクション。何かあったんですか？ぶつからないかどうか。Is collision an occur or not? The distance between the people の話、あと事例の話をします。Okay, I explained about the overview of the lecture series. This is okay, we start the guidance here, and then I put some hints or the clue how we can think about the world and society and biological system and intelligence. And then explaining about the nonlinear equation and the linear equation. This is the kind of basement of the biological mathematics to describe the biological phenomena. Then the first lecture, we start such the explanation, the beginning, and the third one is how to model and the way with the mathematics. And fourth thing is how to simulate it in the computer. And then the fifth the lecture here, and start about think about this way with description and the physics and control mechanism and the information science in the biological science. And we try to connect together the brain, body, and environment in some specific conditions. For example, we have to think of the Bernstein the degree of freedom problem. We have many freedom in the body, but we need to put some constraint to get function, like walking and sitting and something. The second thing, the global environment. It's a kind of the biological nervous system can constrain to generate some adaptive, spontaneous mechanism to generate some possible necessary constraint. Yes, the 13 and 14 is the kind of the case study. One is the automobile control, in like a Google car. It's possible one. And the second case study is the service robot or humanoid service robot or something like that. This is the course of lecture. Okay, you can choose this lecture is appropriate for you or not, then consider seriously, then see you next